Correct reflections are an essential part of making any material appear realistic. If materials are shiny, we expect to see some kind of reflection on their surface. If the reflection isn't there, the shine looks oddly placed, as we're seeing a mismatch between what we know and what we see in the game. In Unity, we'll use reflection probes to sample reflections at points in the scene and apply them to dynamic objects. And this way, we can either pre-calculate or work in real time and optimize our reflection calculation so that our gameplay stays fast and responsive. I've got my test sphere here in the scene, and what I've done is to make that material very smooth and very metallic. Essentially, I have a chrome sphere that moves in my scene, and what we'll see is that those reflections don't quite match what we'd expect. When I press play, we can see that sphere move, and it's reflecting what looks like a bit of the sky beyond. We can see the shadow move across it, but it's not quite matching in the adjacent objects. What I'll do is to put on reflection probes. We could choose to either attach reflection probes to static objects or moving ones, depending on what we need to reflect and what needs to show in the scene. I'll select the robot and add on a reflection probe. What this will let this robot do is sample any reflections in the scene so it appears to match in correctly. Under Add Component, I'll choose Rendering and Reflection Probe. What we can see is I have a wireframe box now around that robot. It's actually quite big. It's centered on that robot and goes under the floor. I'll lower the size of this, looking in the reflection probes under size, and I'll put the size down to a Y of 5. I'm going to leave that reflection size on the X and Z axes where it is, but then I'll move up on the Y axis that probe origin, so it takes in more of the surrounding environment. In our reflection probes then, we have the option here to have baked or real time, and we also have options as to the resolution of the capture. What dictates these reflection probes then is the shininess of that object. Not that there's an actual connection necessarily between the material we've created and the probe accuracy, but that we need to choose if an object is shiny, that it has a better reflection. Conversely, we need to choose that if an object is fairly dull, we need to mute out or, in some cases, have no reflection. As this robot never moves, what I'm going to do is add in a baked reflection onto it. And this way, it'll calculate those reflections and look correct as it's sitting in the scene. If you need to move a probe around further, you can always click on the Edit Probes button and pull the sides of this probe around, extending them back and forth as needed. Clicking on the Move tool allows you to move the object within that probe and position it accordingly. I'm going to leave the type here as baked, and what this means is that this object will calculate those reflections in advance and project them on once. Reflections are calculated as a cube map, where all 6 sides of a cube are rendered in what they would see in the reflection, which is then projected onto the object. From the top menu, choose Component, Rendering, and Reflection Probe, and this will put a reflection probe on that sphere. Because this object is dynamic, we need to have the reflection probe be real time. I'll drop down under Type and choose Real Time. What we can see here in the inspector is that it's got different refresh modes available: on awake, every frame, and via scripting. On awake means when that object is awakened in the scene. This may occur when the scene loads, as it will with most of our Zombie Toys objects, but may also occur when an object is spawned in the scene, as it will with our non-player characters, our zombies. I'm going to choose every frame, which will trigger a near-continuous reflection update for this sphere. This is also exposed via scripting if needed, although that's outside the scope of this courseware. Now I'll press play. What we can see is as that sphere moves, the reflection appears to change. We're seeing the shadow change on it, and reflections are changing across the surface of that sphere, because over every frame that reflection is being drawn in real time. Optimizing reflections requires considerable care, as we need to balance the quality of the reflection and real-time versus baked reflection against performance gains or losses. If everything has a real-time reflection, it's going to bring down our game performance, so we need to be very careful which objects have real-time reflection. Similarly, if we use baked reflections everywhere, our Dynamic objects are not going to match. Their reflections will look off, and they won't appear to be in the same scene as the rest of the game. Most of the objects in this scene are matte, meaning they are fairly dull, not very shiny, and don't need a lot of reflection. However, a lot of objects benefit from a little bit of reflection. We also need to keep in mind what's going to be near our objects, and are there things that are going to be reflecting in them. This dollhouse is muted. It's a matte paint, and so it's not going to have too much reflection. Things like the robot, which are made of plastic, do need a reflection, as do the top and the car on the floor. We can judge then by the shininess of objects and the possibility of other objects getting close to it in calculating our reflections. For now, though, I'll add reflection probes only on those objects that might see something, or reflect it, very close and are already fairly shiny. I'll put a reflection probe onto the train, the blocks, the fire truck and the robot, and also the clock, as it has a glass face. I'll leave the reflection off the walls, dollhouse, and drawers, as those are matte objects. As an artistic choice, I'm going to leave the reflection probes off the floor for the moment. We can always add them in later, but this may be too big for one probe, and we may get some odd reflections or too much of a computation load.